Hello everyone, welcome to this channel MathSKfunde. Today I've got third problem for you in mind tickling problem series. I'm sure previous two problems you must have tried on your own, must have seen my solution also, and you must have enjoyed. Now today's problem is A, B, C, D, and then I have put their dots, is a regular n-sided polygon. If 1 upon AC plus 1 upon AD equal to 1 upon AB, then we have to find n. That means we do not know how many vertices are there and we have to find number of vertices, and that is why I have just written here dots. So I have not written complete polygon's name. Okay. Now you may write or build up your solution on your own. If you wish to do that, you're most welcome. Leave your solution in comment box. That would be helpful for me and for the other viewers also. Or I can give you one hint here. You may build up your solution based on that hint. You're still welcome. And the hint is that there is something called Ptolemy's theorem. I'm not sure how many of you know Ptolemy's theorem. Ptolemy's theorem is for a quadrilateral ABCD, and it says AC into BD is less or equal to AB into CD plus BC into AD. And equality occurs only when ABCD is a cyclic quadrilateral. Now, whenever we write here like less or equal to or greater or equal to somewhere, it is our prime duty to mention when does equality occur. And that is why I have mentioned here equality occurs only when ABCD is a cyclic quadrilateral. Okay. Now, what is the meaning of this statement? If instead of remembering it in terms of A, B, C, D, etc., it's better to remember as that product of the diagonals is less or equal to sum of the products of the opposite sides. If you can remember like this, I think that would be more easier. Now I'm giving you some time, you think over it, and then I'll get back to you. So could you think over it? Now I will do one thing. I will draw a figure for you. I will explain my solution to you. I hope you can understand that very well and then compare your solution with my solution. Most welcome. Now I draw the figure and I show that polygon as A, B, C, D, E, F, and I have left this F as an open end as I do not know how many vertices are there. And also, if you can see that I have given these side lengths name as X, then I write diagonals in various ways, Y, Z, W, etc. Now, whenever you are leaving one vertex and say you join A to C leaving B, then I'm naming this as Y. Now, whenever you join B to D leaving C, I'm naming this also Y. Means whenever you leave one vertex and when two opposite vertices are joined, it is named as Y. Now, whenever you leave two vertices, like say, for example, B and C, and if you join A to D, I'm naming that as Z. Now, when you leave three vertices, say B, C, D, and if you join A to E, I'm naming this as W. I'm explaining to you how I have written those names X, Y, Z, W, etc. so that my writing of next few steps would become easier for me to write. Instead of naming it as A, B, C, D, etc., it's better to write in terms of X, Y, Z, W. Now, if I apply this Ptolemy's theorem on A, C, D, E, on this quadrilateral, if I apply, then product of two diagonals would be YZ, and products of two opposite sides means X, W, these would be opposite sides, and Y, X, these would be two another opposite sides. So in A, C, D, E, I should write that X, Y plus X, W, that would be your this right hand side, that would be greater or equal to now diagonals product, that would be YZ. But have you observed here one thing, that this polygon is regular n-sided polygon. Regular polygon means the one which can be inscribed in a circle. So this polygon can be inscribed in a circle. So obviously ACDE would be a cyclic quadrilateral. Don't forget that. So equality would occur here, right? Instead of less or equal to, I would write equal to sign there. Okay. So now my statement would be xw plus xy equal to yz. This is my first equation, which I have obtained from Ptolemy's theorem. Also, we have not yet used this condition, 1 upon AC plus 1 upon AD equal to 1 upon AB. So let us use that condition. And now I will be writing in my nomenclature that same condition, 1 upon AC plus 1 upon AD equal to 1 upon AB. And that would come out as 1 upon Y plus 1 upon Z equal to 1 upon X. Simplify this. That will give me XY plus XZ equal to YZ. Now we have equations here. One is XY plus XZ plus, sorry, equal to YZ. And the first one was XW plus XY equal to YZ. Now compare these two and you will see now here also I have XY and even in this I have XY, and on right hand side in both I am getting YZ. That means remaining quantities also will have to be equated, and that would actually lead to W equal to Z. Now once you get W equal to Z, this would decide how many vertices are going to be there. That means this W and Z basically they are equal. So you can continue in this manner here and you will finally get that n is nothing but 7. So it is a n-sided polygon. And how would it look? It would look something like this, I guess, right? Now this is my solution and I have found n equal to 7. You please write your solution in comment box. I would really appreciate that. I will get something for you in next turn. Till then, stay tuned. Thank you.